Today we're going to do matrix inverses, which is the last section on matrices. There are a lot more topics on matrices generally. In fact, there's a couple college level courses that you can take, but this is just an intro. Before you go through this, please go through the PowerPoint presentations. This one, I'm not going to go through every detail of it. Just flip through it, make sure you're familiar with it, take some notes out of there, and then come back to here. Also, when I say pause and do a problem, please do that. It'll be like using whiteboards in class, and you'll get a test as to whether you're getting the material. Okay, so we're going to cover two things in matrix inverses. The first thing I'm going to do is introduce the idea of an identity matrix and an inverse matrix and how you calculate it. So basically kind of the mechanics up here, just like we were doing addition and subtraction. Now we're going to do inverses, which is, by the way, the moral equivalent of matrices of division. The second thing we're going to do is use inverses specifically to solve systems of equations. Again, we've been doing most of the time in this matrix section. Again, this is not the major application of matrices, matrix inverses, but it's something we're going to do just as an introduction. Okay, so I'm going to start with introducing the identity matrix, because we're going to use that when we do inverses. So the identity matrix is the matrix equivalent of the number 1, except matrices aren't a single number, they're a block of numbers. So to create an equivalent of 1, you just put 1s down the diagonal of your matrix. Say this is a 4 by 4, and then you put 0s everywhere else. There you go. This is an example of a 4 by 4 identity matrix. Identity matrices, 1 basically has to be square as well. In other words, the number of rows has to be equal to the number of columns. So this is a 4 by 4. If I had a little simpler example, I'll show you how identity matrix works. Like, for example, a 2 by 2. Again, it has to be square. What you do is if you multiply some matrix, I'll make it up, 2, 3, 4, 5. If I multiply it by 1, if you multiply a number by 1, you get the number itself back. If you multiply a matrix by the equivalent of 1, you will get the matrix back. So again, we'll do matrix multiplication from a couple lessons ago, or actually it's last lesson. Go row times column, and you get 2 times 1 plus 3 times 0, or 2. The next one you get is 2 times, do this column, row times column, 2 times 0 is 0, plus 3 times 1 is 3. Then do the second row, 4 times 1 is 4, plus 5 times 0 is 0, so that's 4. And then finally 4 times 0 is 0, plus 5 times 1 is 5. In other words, I took this matrix, I multiplied by I, identity matrix, and I got the matrix itself back. Also, if I multiply I times the matrix, the same thing will happen. 1 times 2 plus 0 times 4 is 2, 1 times 3 plus 0 times 5 is 3, 0 times 2 plus 1 times 4 is 4, 0 times 3 plus 1 times 5 is 5. Again, so what does an identity matrix mean? It means that A times I will give you A, and I times A will also give you A. It's the equivalent of 1. Okay, now we're going to do the inverse. The inverse matrix, that was just identity the last part. An inverse matrix is a matrix that when you multiply it by so you take an A, matrix A, and you multiply it by its inverse, you get 1. And also if you take an inverse and multiply by that same matrix, you also get I. So think of it as the equivalent of division or reciprocal. So this is like 2 times a half, you get 1. Or a half times 2, and you get 1. A half in that case is the reciprocal of 2. So think of this as a reciprocal or a division. And we'll use it as division when we solve systems. Sometimes you cannot find an inverse of a matrix. I'll talk about when that occurs. If you cannot find an inverse, it is called a singular matrix. It means it has no inverse. What this means when you use this to solve systems equations, if you get a singular matrix which doesn't have an inverse, it means the equation has no solution or infinite solutions. Basically, you can't solve it. If it does have an inverse, it's called a non-singular matrix. That does have an inverse. And again, we'll use that when we solve equations. Okay, now how do you calculate inverses? There's several methods for doing them. I'm going to show you one for doing 2 by 2 and one for 3 by 3. After that, it gets just horrendous to do them by hand, and I'll also show you how to do them in a calculator. So if you have a matrix, just put in letters here. This is in your presentation as well. A, B, C, and D. Just random 4 numbers in a 2 by 2 matrix. The way you find an inverse of a 2 by 2 matrix, if I want to find that inverse, is you first put in front of a new matrix the multiplication of the diagonals subtracted from each other. What you do is you multiply A times D, and then you subtract B times C. It's a little clearer way to do with numbers. That's just a fraction that's going to sit in front of every one of your inverses. And then inside the matrix itself, the inverse, to create the inverse, you switch the A and D. So where A was, you put D, and where D is, you put A. And then you B and C, you make negative, like that. And that will give you an inverse matrix for 2 by 2. This number AD minus BC is called the determinant of the matrix. And you also write it like this: A, B, C, D, with straight arrows on straight lines on the sides as opposed to square brackets. This is why I said a couple presentations ago, make sure you use squares for these. This means the determinant. If this determinant, which is AD minus BC, if AD minus BC equals 0, you're dividing by 0, and you cannot find an inverse. And that means your matrix is singular from the last thing I just said on the last page. Okay, so I'm going to numerically do a couple of these. First, I'll start by doing one just for your notes, and then I'll have you do a couple. So let's take this matrix, 2, 3, negative 1, 2. I'll call that A. And I'm going to find A inverse. And then I'm also going to demonstrate that it's the inverse. So first of all, I'm going to do the matrix part first without the fraction in front. Just reverse these two, which doesn't do anything because they're both 2. And then make those negative. So 3 becomes negative 3, and negative 1 becomes positive 1. Okay, in the front of that, you have 1 over the determinant. The determinant is 2 times 2 minus 3 times negative 1. Or, in other words, that front part is 1 over 4 plus 3, or 7. Okay, so in other words, the inverse matrix is 1/7 of 2, negative 3, 1, 2. I tend to leave the 1/7 outside, although you can put it in front. This is also equal to, or put inside. This is also equal to 2 7ths, negative 3 7ths, 1 7, and 2 7 by scalar multiplication. But I tend to keep the 1/7 outside, and you'll see when we start solving equations with this why I do that. Anyway, there's your inverse. So I'm going to take that right up here and then show you what an inverse does. There's my inverse. Now, what I said at the front is if I do A times A inverse, I will get 1. So I'm going to do A times A inverse and see what I get. 2, 3, negative 1, 2. Inverse is 1/7. I can put the 1/7 in there. The 1/7 you actually move around, so I'm just going to put it in front of the whole thing, because I could put the 1/7 inside there and create a giant mess, or I'll just put 1/7 out front. 2, negative 3, 1, 2. Note, I can do that 1/7 with a number. I couldn't put the matrix out front, because matrix order matters. This is just number, like put multiplying by 2. Doesn't matter where I put the multiplying by 2. Okay, so I got 1/7 out here, and now I'm going to do the matrix multiplication. 2 times 2 is 4, plus 3 times 1 is 7. 2 times negative 3 is negative 6, plus 3 times 2 is 6. Negative 6 plus 6 is 0. Negative 2 plus 2, 0. 3 plus 2 times 2 is 4, 7. And now I can multiply the 1/7 through and get 1, 0, 0, 1. I multiplied A times its inverse, and I got I, the identity. Notice the reason you can see why I wanted to put the 1/7 out. If you put the 1/7 in here, every one of your multiplications is going to have a fraction in it. which would be painful. At this point, I just had to multiply at the end, and it was a very simple multiplication. So keep the fraction out front. And most of the time, you are going to have a fraction there because it's 1 over a number. Okay, now I'm going to do the inverse. Let's do the opposite one. I'll just do it down here. A times, so A inverse times A. Up here, I did A times A inverse. Now I'm going to do A inverse times A. Again, I'll put the 1/7 out front. A inverse is 2, negative 3, 1, 2 times 1/7. And then A is 2, 3, negative 1, 2. So I get 1/7. I'm running out of room here.
I'm just waiting to about the logistics of that.
Hold up just a second. And, okay, that was my wife talking over me. So it should be in the video. So now we'll do 1/7 here again and do row times column. 4 times plus 3 is 7. 6 minus 6 is 0. 2 minus 2 is 0. And 3 plus 4 is 7, which again is 1001. Okay, I'm going to have you guys do one. Let me write up 2 new numbers. It's going to use the one from the presentation. I don't know what that is yet. So A I'm going to call 2, negative 6, 1, negative 2, and I want you to find A inverse. Okay, pause the video. Do that problem. Okay, now coming back, hopefully you got the right answer. We are going to do A inverse down here. You flip these 2, so where the 2 is, negative 2 is, where the negative 2 is, 2 is. It's not a change of sign. That is just flipping the order. This one on top becomes 6, that becomes negative 1. And now in the front, I put 1 over. 2 times negative 2 is negative 4, plus 6, which is 1/2. I have negative 2, 6, negative 1, 2. This time I might put the fraction through just because it's a half. And you can do that. This is negative 1, 3, negative 1/2, 1. And let me just verify because I'm doing this real time. Negative 1, 3, negative 1/2, 1. I'm going to multiply by 2, negative 6, 1, negative 2. And see that I get 1001. If I were in class, you guys could correct me if I was wrong. This will make sure I'm right. Negative 2 plus 3 is 1. 6 minus 6, 0. Half of 2, negative half of 2 is negative 1, plus 1 is 0. And 3, negative 6 times negative 1 is 3, minus 2 is 1. Check, worked fine. Okay, I'm going to pause here just a second. I'll come right back. Okay, we're back. That was 2 by 2 matrices. Now we're going to do 3 by 3 and above. These are rather painful. I'm going to do one example, and then I'll show you how to do it on a calculator, which is the way you'll actually do it most of the time in reality. I'm going to start, what I'm going to do is actually show you the method first, which is I'm going to create a matrix. Say I have a matrix A. I'm going to create an augmented matrix and combine A with the identity right next to it. And then what I'm going to do is I'm going to row reduce until, just like we did with Gaussian elimination, I'm going to row reduce until I get I on the left, and on the right will be A inverse. Basically, I'm just doing division by row reduction. So I'm going to start with A on the left, I on the right, and I'm going to convert I. I'm going to do row reduction until I get I on the left, and that will give me A inverse as my operator. And I can apply this to any size. I could do it with a 2 by 2 as well, but the equation that I gave you before is a bit simpler. Okay, so now I'm going to give a relatively simple problem, which is, I think, maybe one on your homework, actually. So you might want to at least write this one in your notes when you're doing it. Okay, so I'm going to start with a matrix, which I'm going to use. I'm just going to write it directly in, which is 1, 0, 0. I'm going to leave tons of room because this gets to be, it's going to be a lot of operations. 3, 4, 0, 2, 5, 5. Again, 1, 0, 0, 3, 4, 0, 2, 5, 5. That's going to be the A I'm going to use. That's A. And I'm going to find the inverse of that matrix at 3 by 3, which will also be a 3 by 3. What I'm going to do now is append an identity next to it of the same size. And I'm going to do row reduction on this until I get this part over here to be the identity, which is how we did row reduction before. And when I'm done, this will be the inverse. So again, now we'll just do elimination. See if I can, how many of these I can fit in here. I'm going to first get rid of this -3, or this 3 rather here. I'm going to multiply the top one by -3 and add it to the second one. If I do that, I get -3 times 1. So first of all, I'm not going to change the top row because that's exactly what I want it to look like right now. But the second one, I'm going to go -3 times 1 is -3 and add it to the 3. And I get 0. Just how I do elimination. Same thing over here. I'm going to go -3 times 0, which is 0, plus 4 is still 4. -3 times 0 is 0, plus 0 is 0. But now I have to do it to the part over here as well. -3 times 1 is -3, plus 0 is -3. -3 times 0 plus 1 is 1. -3 times 0 plus 0 is 0. So I eliminated basically the 3 from here, and that gave me this, which looks quite close to what I need, which is the identity on the left. Now I'm going to do multiply the top one by -2 and just repeat that for the bottom row. -2 plus 2 is 0. 0 plus 5, sorry, 0 plus 5 is 5. 0 plus 5 is 5. -2 times 1 is -2, plus 0 is -2. -2 plus 0 times 0 is 0, plus 0 is 0. -2 times 0 plus 1 is 1. Okay, so we're close. Now I'm going to make this 5, but before I do it, I'm just going to divide by 4. Because normally I wouldn't do this, but this is kind of a pain to deal with, because I'd have to multiply this one by -5 and this one by 4 in order to get rid of that. So instead, I'm just going to take the middle line and divide by 4. And that gives me most of the way I want to get there. Unfortunately, I'm making a bunch of fractions on the right, but it's not too messy. -3/4, 1/4, and 0. That's divided by 4, and the bottom one I'm going to divide by 5. 0, 1, 1. -2/5. Like I said, normally I wouldn't do this. I just know this is going to turn out better, so it's just a shorter way to do it. And 1 divided by 5 is 1/5. Kind of this awful fraction thing, but I only have that one left to get rid of here, so it's not that bad. The way I get rid of this one is I multiply the middle one by -1 and add it to the bottom one. 0, 0, 0, 1, 0. So the bottom one becomes -1 times 0 plus 0 is 0. -1 times 1 is -1 plus 1 is 0. And -1 times 0 plus 1 is 1. And now I have what I need on the left here, which is going to be my inverse. I get still 1, 0, 0. This stays the same, -3/4, 1/4, 0. And the bottom one becomes 3/4 minus 2/5, which is horrible. I'll leave that for a second. This one is just -1/4 plus 0. This is 0 plus 1/5, which is 1/5. So all I have to do is this. 3/4 minus 2/5. Common denominator of, don't know why I just erased that, of 20 will give me 15/20 minus, is that 8/20 or 7/20. So there's my inverse. This stuff up here, this is now the identity. That's my inverse. 1, 0, 0. Need a lot of room here for these fractions. -3/4, 1/4, 0, 7/20, -1/4, 1/5. Yikes. The reason I put that on the side is I'm going to do this with the calculator now to show you how that works. Anyway, just walk through that again, make sure you get that. I'm not going to give a bunch of examples on that because it's not actually the way most of them are done, but I wanted to just show you that it does work. Okay, now I'm going to show you how to do that on the calculator. Okay, I forgot my original matrix, which isn't good. I'll write it down again. 1, 0, 0, 3, 4, 0, 2, 5, 5. Okay, you're not going to be able to see this on a calculator mostly, and you may not have this calculator with you, but I'm going to show you how you do these in calculators. If you got a version of the TI, it'll work exactly like this. Otherwise, you can get an emulator online that will work like it. Okay, so first of all, if you're going to enter matrices, you're not going to be able to see most of this. There's a blue button right above your x to the -1, which says matrix. That's where all the operations are. So you go second matrix. You'll see things like names, math, and edit. Names are just how you pull the matrices up once you've entered them. Math is all the things we've been doing, like determinants, their identity matrices, reducing row reduction, which we did in Gaussian elimination. They're all in here. If you want to just multiply, you can just multiply, or do inverses. I'll show you how to do that in a second. And then edit is where you actually create your matrix. So go to edit if you're doing this live. Hit return, and you'll have a matrix. It'll say matrix A 1 by 1. I have 0 in it, so I have nothing else in information right now. So I'm going to make it a 3 by 3. I'm going to put 3 by 3. It'll give you a blank, and now just enter the numbers in. 1, 0, 0, 3, 4, 0, 2, 5, 5. By the way, I have no illusion you can actually see these, but I'm just giving you the process. Okay, so there's my matrix now. And now if I want to do an inverse, all I do is get out, so I can quit. And I go second matrix A, I call it up. And then you just use the inverse button, which is x to the negative 1, right under the matrix blue statement. Like that. Hit enter. And you get this in decimals. If you want to create the fractions, hit math, convert to frac, the first number. And there it is, 1, 0, 0, negative 3/4, 1/4, 0, 7/20, negative quarter, 1/5. Okay, that's it. Anytime you get anything above a 2 by 2, I would just use a calculator. Okay, now I'm going to do an application of this, which is, this is not the only application, but it is the one we're going to go through, which is solving equations with inverses. With inverses. We've already used several methods to solve equations. One was using Gaussian elimination in matrices, or Gaussian elimination actually in variables. Then we use what's called reduced row echelon reduction, reduced row echelon form, which is the one where you get like 1, 0, 0, 0, 0, 1, sorry, 0, 1, 0, 0, 0, 1, and the answer. That's what we did on the first matrix lesson. This is also, by the way, in your calculator. It's called REF, and it will do it for you. And the last method we're going to do is inverse matrices. The way you do inverse matrices, I'm going to give you the theory first. If you got some matrix A times some variables x, and you have it equal to some numbers b, for example, I'll give you an example, 1, 2, 3, 4, x, y equals 2, 1. This is an equation. If you were in a matrix multiplication, this is 1x plus 2y is 2, and 3x plus 4y is 1. I'm just going to generally write it as ax equals b, because then this x can represent 20 variables I want. And this could be, for example, a 20 by 20 matrix, and this could be 20 by 1. You can use it for anything. I'm going to solve this. The way I solve this is I get rid of the a. How to get rid of the a? I multiply by a inverse on both sides. That then gives me x, my variables, equals a inverse times b, which is sometimes just shortened to x equals a inverse with a little factor symbol up there, b, like that. So what does this mean for solving something? Get rid of this here. Don't need that anymore. X equals a inverse b. It means if I can find the inverse of the matrix in front of my equations and just multiply it by the numbers on the right, I'll get my answer. So let me give you an example of that. I'm going to use the one again for the notes. I have 2x minus 3y equals negative 13, and 4x plus y equals negative 5. So first thing is convert to a matrix equation. 2, negative 3, 4, 1 times x, y equals negative 13, negative 5. There we go. My answer is then going to be finding the inverse of this, which I will call a. X equals b. And this is not singular x, this is a matrix of variables, which one of them happens to be x. Now I'm going to find a inverse, and I'm going to multiply by b. So let me just find a inverse first. For the inverse, just flip these two. 1, 2. Change those signs. 3, negative 4. And now in front put the determinant, 1 over the determinant. 2 minus 12. That's likely. 2 plus 12. Which is 1/14. 1, 3, negative 4, 2. And then I'm going to multiply by that by negative 13, negative 5. Doesn't look like it's going to work, but it will. Keep the 1/14 out for the moment. This is a 2 by 2. This is a 2 by 1. We're going to end up with a 2 by 1, which is why I wrote that right there. So now I go negative 13 minus 15, which is negative 28. And 52 minus 10 or 42. Turns out those are both divisible by 14. And this is again why I let the 14 1/14th up front. This is a negative 28 divided by 14 is negative 2. And 42 divided by 14 is 3. And that's it. So my answer is negative 2, 3. And I can check that into the original and find out if that works. Let me do that. Negative 4 minus 9 is negative 13, and negative 8 plus 3 is negative 5. It worked fine. So you can see this is probably the simplest way to solve equations. If, by the way, when you do this determinant was 0, then you wouldn't get any solutions. And the reason you wouldn't get any solutions is if the determinant is 0, this is just a multiple of that equation. So that means the answer is either all answers or no answers, depending on what's on the left on B. Okay, we're going to do one more, and I'll have you do it. By the way, if you have 3 by 3, just go into your calculator, do the inverse. Your calculator and multiply by B. So I'm going to do a little messier one for the notes. 18x plus 12y equals 13, and 30x plus 24y equals 23. Okay, I'm going to have you do that. This one, it's going to require a calculator because there's some really messy numbers in here. All the answers don't turn out that messy. So try that one. Pause it here and come back. Okay. Now I'm going to go through it. First, I'm going to create the matrix, which is 18, 12, 30, 24. And I'm going to write that, and I'm going to find the inverse A. And I'm going to find A inverse, and I'm going to just multiply it by B, which is 13 and 23. A lot of big multiplication here. So first of all, 18 times 24, let's do 1 over the determinant. Flip these over. It's 24 and 18. Those are both negative. Ugly, as I said. We're going to multiply by 13 and 23. And then in the front, I get 18 times 24. I'm going to use a calculator for that. Minus 12 times 30, which is 72. That really doesn't look like it's going to work out. Now I do matrix multiplication for this part, and I'm again just use a calculator. 24 times 13. Put it right here. Plus negative 12 times 23. 36. And then negative 30 times 13 plus 18 times 23, 24. And that answer is 36 over 72 and 24 over 72, which is 1/2, 1/3. And there's my answer. Hopefully you got the same. Okay, you could go back and check those again if you want. Actually, that's easy to do. Half of 18 is 9. Half of a third of 12 is 4. 9 plus 4 is 13. Half of 30 is 15. A third of 24 is 8. 15 plus 8 is 23. That works. Okay, that's it. Work on homework 24, which is matrix inverses. That's the last section of matrices. We'll have a review after this. Thanks for tuning in.